Well, good afternoon, everybody. My name is Jonathan Taylor. I'm the Technical Marketing Manager for Civil Survey Solutions, and it's my pleasure to welcome you to this technical webcast on civil site design, civil 3D outputs. Now, in a moment, I'll introduce you to your presenter today, Andrew Banson, who's that wonderful fresh face you can see on the screen in front of you. So he's our application specialist and development guru who's been with the business for a very long time. You'll have no doubt heard his voice on many a video and webcast. And he's really heading up a lot of the heavy development in this particular part of civil site design. Andrew, you there?
Yeah, so look, I mean, the emphasis of today is demonstrating the new corridor export tools. And this is a big thing for us and our user base, because it means that our users can participate in BIM workflows. That's probably the number one thing.
Great. Yeah. Now, I suppose for those of you who may not be aware, this particular functionality is actually available in the latest version of the software. So what Andrew is going to be demonstrating today is available on version 20.3, I think. Is that right, Andrew?
Yeah, that's right.
Yeah, 20.3. So yeah, in respect of being able to have access to all of this content, it's available now. We will be discussing at the end the availability of an e-learning course which has been created for this specific functionality in mind, which we'll reference at the end. So if you are wanting to go ahead and learn this particular functionality, then we'll show you how you can do that at the end. So Andrew, on that, I'll hand over to you.
Thanks, Jonathan. Okay, so look, as I mentioned, we've been working very hard recently to build a set of tools that allow for a better connection between civil site design and civil 3D. Now, there are a number of reasons why we're doing this, but the primary reason is the growing interest in BIM. So when you install the latest version of civil site design, version 20.3, there will be a new tab named Civil 3D Outputs with a bunch of new commands and some existing commands as well. So in today's session, I will be demonstrating these new commands, but as I said, the emphasis will be on the CSD model to corridor model conversion tools. Now, we have actually almost finished the CSD pipes to Civil 3D Pipe Networks conversion as well, and that should be released in a month or two. So, what is BIM? I wanted to start off by quickly explaining BIM and also the Ifc file, which is often associated with BIM. So, BIM is an intelligent model-based process that allows for architects, engineers, GIS analysts, construction and many other professionals to work collaboratively and with a shared data source. Now, what we're seeing in Australia is certain construction projects actually being BIM mandated. So more specifically in regards to our user base, a lot more of our users are saying that for certain jobs, they are being asked to build 3D models and perhaps even produce an Ifc file. So in time, the days of only producing points and sections for construction will fade away as we sort of move to more solid-based stuff. So the Ifc file stores a 3D model along with other attributed data and information. And this data could be construction information, asset information, or even data for analysis and simulation. Now, Ifc is often seen as the currency for BIM. However, even the DWG file can be seen as a file that can be used in BIM workflows. Now, there actually are international standards that have been drawn up and currently worked on, which describe how data, such as civil data, should be stored in the Ifc. There is an organisation called Building Smart who developed these standards, and in time you will become familiar with the Civil Ifc standard. So one of the benefits of a corridor and a Civil 3D Pipe network is that once you have these, you can produce an Ifc file or produce solids showing the curb and gutter in all its glory rather than just sort of the top surface tin. So, and look, we felt that it was important that when your project was completed in civil site design, that you could participate in these BIM workflows easily. So just to very quickly run through today's agenda. I'm going to show the Civil 3D Output tab and the new commands that feature on it. We're going to output a corridor model, and I'll demonstrate that. Before we do so, I will just jump into the settings just to show you exactly how it works. So we'll spend a little bit of time there. At the end, I'll show you a whole bunch of useful new commands. I do want to give you a sneak peek at the Csd Pipes to Pipe Network, because it's at the stage now where we can actually show you, and then we will finish up with a bit of a Q&A session. The other thing I want to mention is a lot of you might not know too much about the corridor model. Maybe you've never built one before. And I'm going to be throwing a few terms around in this session, such as sub assemblies and regions and targeting and that type of thing. So given that we're now working with the corridor, now and outputting one, it is probably important that our user base understand exactly how the corridor works, because you might want to take that corridor that we output and edit it, split up regions, fix up targeting, that type of thing. So next Thursday, I'll be running another webcast, but it's basically going to be a 101 on corridors, and I'll create a basic road, talk about assemblies and all that type of stuff. So that'll be next week. Yeah, if you're keen, then make sure you register for that one. So as I mentioned, when you install the new version of Civil Site Design, there is a new tab called Civil 3D Output. Now, if that tab, for whatever reason, doesn't appear, then what you need to do is type unload CSD in the command line, unload CSD, and run the command and then restart Civil 3D, and then this command should appear. So I'll just do a quick run through on what's on the tab, but I will come back a bit later in a bit more detail. So as I mentioned, some of these commands are actually existing commands. We just thought it was a good place to put the Civil 3D outputs in the one spot. So commands like set out, this is the old current multi-object set out command, export surfaces, export to Civil 3D surface. So they're all the same commands. What's new? Feature lines from model. This is pretty cool. You can pick a model. Feature lines are outputted. Export profiles is a command that's been the software for a while, but we'll go over this because it's pretty cool. A new command is profile from codes. So for any code on your model, say for example this footpath code, I can actually output an alignment and a Civil 3D profile. And there's some other cool tricks you can do, which I'll show you a little bit later. So we have a panel dedicated to the corridor output and a panel dedicated to pipe networks. I am running a beta, so this is functionality that's coming soon. So in regards to the CSD model that I'm going to demonstrate being exported to a corridor, I've actually already created some roads. I've created some intersections, a cul-de-sac up the top, and I've also added a variation. I might just open up a cross section here. All right, so I've added a variation to an alignment called left edge control. And the reason why I'm pointing this out is when the corridor is built, this variation will be set up as a target on the corridor. So I'll point that out. But just remember, we've got this variation here as well. The surface that I'm sampling is a Civil 3D surface. So if the aim is to produce a corridor, you want to make sure you're using Civil 3D alignments and Civil 3D surfaces as the sample surface. Okay. So when we embarked on the corridor export tool, we wanted to ensure the corridor was built in the same way a user would build a corridor, and allow users to reference particular sub-assemblies or even sub-assemblies that they have created themselves. So if you understand how the corridor works, then you can edit it directly. We also wanted to support all CSD models, including models made using Model Builder. This was important because a lot of users like the flexibility that Model Builder brings, particularly when working on string-based design projects. So if you build a model using Model Builder, you can export a corridor of that. So the first command I want to show you is exchange settings. And this is where all the setup pretty much happens for the conversion. And let me just open up. I shouldn't have closed that cross section. Let me just open that up again. Okay. So this is what we're calling the exchange settings for the corridor. Now, when you install the software, you will see that there's a whole bunch of what we're calling conversion files that will be installed. So there's one here called Civil 3D subs, which means that it references the stock sub-assemblies that come with Civil 3D. We have one called Civil Site Design subs. Basically with this one, we created our own sub-assemblies using the sub-assembly composer so that we could get a better match on the output of the corridor. And I'll explain what that means a little bit later. There is one here called Shape, but you'll probably never use it. If you wanted to test the corridor output today, when you go to export, I would use either the Civil 3D subs metric or the Civil Site Design subs metric, either one of those two. We have set another one up for the Australian country kit. So when you install Civil 3D, you can install it with the ANZ country kit. You get some different curb sub-assemblies. There's an RMS one, WA main roads, templates, etc. And so we've created a conversion file that works with those sub-assemblies. So to demonstrate this form, I'll just keep it simple and go with the Civil 3D subs. So how this works, and actually let me just turn on the codes here. Okay. So how this works, on the left-hand side, you'll see that we have what we're calling correlation groups. So we've got road, curb and gutter, footpath, batter, etc. Now, if I was to say, click on curb and gutter, in this view here, we can see three codes, INV, TK, BK. So those codes are the Civil Site Design codes, and if the software finds those codes in that particular order, then in this case, it has been told to apply the this sub-assembly called Urban Curb and Gutter General. It's a standard stock sub-assembly, right? So, so really how this works is it looks at your cross-section, even cross-sections after variations are made and model edits are made, looks for the groups of codes and essentially replaces those with a sub-assembly. So if we looked at the pavement here, this lane, if it finds EB, then it applies this standard lane super sub-assembly, okay? Now, I'm not going to go into too much detail on all of this because of time. However, as Jonathan mentioned, we did actually create an e-learning course dedicated to the setup of this, and we actually run through building a conversion file from scratch. But anyway, so we pick the codes from CSD, and then we specify the sub-assembly. Now, if I was to click on Select Sub-Assembly, it would scan, or it scans my computer for sub-assemblies, and list them. So a lot of these are stock sub-assemblies, but some of them are from the Australian country kit, and then I can just go and select that. A lot of users, proficient corridor users, will actually create their own sub-assemblies, intelligent sub-assemblies using the sub-assembly composer. And if you do that, the sub-assembly composer outputs a PKT file. So if I was to click on import PKT, I could actually go and select a sub-assembly that I have created myself. So the next part of this is what we call parameter mapping. So sub-assemblies are made up of parameters. Each sub-assembly will have different parameters. These parameters control different things. So for example, for this lane super elevation, I have a parameter called width. I've got one called slope that controls the slope, and I've got some that control the pavement and sub-base thicknesses, etc. Okay. So how our conversion works is we take outputs from CSD and we map them to the parameter. For example, in this case, we want to take the width of EB and we want to apply it to the width parameter. Right? The slope on the parameter, we want to pass in the slope as a decimal value onto it. So it's really just about going through and mapping CSD outputs, and there's a lot of CSD outputs here. In this list, there's all the different subgrade properties. There are batter details, etc. So there's a lot in here. Now, not to go too deep with this, but if we look at, say, something like the urban curb gutter subassembly, it has a parameter called dimension E. And you can see here under CSD property, I've told it to use dimension E. Well, what dimension E is what we call a custom property, because I can't just, one of these sort of default properties doesn't cut it. I think with dimension E, it's a distance that includes the top, what does it include? I'll just open it up here. Yeah, so the dimension E on this subassembly is actually the top of curb width plus the back of curb width. Okay, so what we have done is we've come up with this ability to create custom properties, and so I've called it dimension E, and all it is the TK width plus the BK width, and then we're able to pass in the right parameter or the right property onto the parameter. Okay, so we've gone to that level as well. There's a lot of effort and work that's gone into this so that the corridor that is produced is an accurate match. So yeah, that's an example of the road, the curb. If I have a look, there's one here called batter. It just uses a standard daylight subassembly. The difference here is we've actually told, we've gone target sampled surface, which means that this subassembly will be set up to target whatever our sampled surface is, which is why your sampled surface should be a Civil 3D surface. Now, you might be thinking, well, what happens if I name a code that is not listed in here? So there is a default group, and if you have a code, L something or other, L R wall or whatever, and the conversion files, there's no group dedicated for it, then it will use default. And for default, we just have a very generic subassembly called link width and slope. So if it finds a code that doesn't match any group, it'll just use this one. And you can see here that default group has been ticked on. So, and in fact, to create one of these conversion files, you need to have at least one default group. So we created another conversion file called Civil Site Design Subs. And I mentioned that for this one, we actually created our own sub-assemblies. with all the new versions of Civil Site Design, it does install with the new with these sub-assemblies. Now, the reason, as I said, the reason why we created them is so we could get a better match. And say, for example, this default section, there's a lot of things you can do with Civil Site Design sub-base. I mean, you can extend it beyond its section. That extension, you can change the slope and all of that type of thing. And the stock sub-assemblies that came with Civil 3D didn't really handle those types of things the way that we do it. So we build our own sub-assemblies, and for a lot of those different parameters, you know, we're able to get a perfect match. Okay. Now, for our custom sub-assemblies, you will see a help button. And if I just open that up, let's move this onto the main screen. We've got a, just like how you can access help for sub-assemblies in Civil 3D, we've created a help system for all our sub-assemblies so you can see how they've been created, what you can do with it. Right, but just to recap, the Civil Site Design subs just allows you to get a better match, particularly if you're doing a lot with the sub base. Cool. Okay, so that's probably enough of this form. So I won't go too much deeper on that. I think what I'll do next is just actually go and export out a corridor. So this job is just total model. What I'm going to do is run the export corridor command, and this form appears. So I name the corridor. I'm just going to call it the default new corridor. I pick the model. As I said, model builder models are supported here. And then I pick the conversion file. So this comes from the form that we just saw, and this button will open that form. You can assign these conversion files based on different templates. So for different templates, apply a different conversion file. So you can go to that level if you want. Next step is really just to pick the different styles. So what corridor style you want to use, code set on the corridor. The software is going to create some alignments, perhaps. So when we create alignments, you pick what style, what labels get applied. And the other thing we're going to do is create a whole bunch of Civil 3D profiles. And so you can pick the style of those and the label set. Now, when you run the corridor export, there is also the option to show a log. This is actually quite a thorough log. And so if you were experiencing issues with the corridor, it wasn't turning out the way you wanted it, or something wasn't right, feel free to lodge a tech support, attach that log, and that will help our development team out a lot to determine what might be going wrong. But the beauty of the log is everything that happens gets listed in there. So next step is really to just click on Export Corridor. And when I click on Export Corridor, the software will ask me to locate the assemblies. Now, the assemblies on the corridor are basically what we would call templates. Okay, so I'm just going to pick a location for those. Now, when we run export, there is a lot of things that happen. The software needs to convert the CSD data, the assemblies need to be built, and maybe sub-assemblies need to be imported. Alignments and profiles are created. Regions are added when there are template changes or variations made. Targeting is set up where you have intersections or where you might be widening to an alignment. And parameters at certain sections might need to be overridden. So there's certainly a lot happening when you run an export. The corridor, well, there are a lot of moving parts that make up a corridor. The corridor is fantastic once you have one, but there's often a lot of work involved when building one. To build this corridor manually that I have now, it could probably take me an hour. Okay, so let me go through and show you what we have here. So listed here are the assemblies. So you liken these to templates in civil site design. So all the assemblies get created. I've got the corridor, so if I go to the tool space, there's a new corridor, and I can go and select that. So that's the corridor's been built. All of these sections, the frequency of the baselines on the corridor will all align with the sections of CSD, right? So we're going for an exact match. If there's a section added in CSD, you will get that section added to the corridor. So let me just open up the corridor properties for a sec. And this section here, this parameters tab, is pretty much like the main command center when you're building up a corridor. Now each road or each string is pretty much a baseline. We use a baseline, and each baseline will have an assembly. Each baseline will be made up of different regions, and the different regions will have assemblies applied to them. I'll talk more about this in my session next week. So if we have a look at road 1, this road that's highlighted red, I can see the regions that the software has created. And if I highlight this second last region, this one here around the corner, that region's been created because of the variation I added to widen to an alignment. So the equivalent to that on the corridor is a target, a width target. So if I was to click on this button with the 3 dots, I can see that my variation has been turned into a width target to the left edge alignment. So if I was to go and graphically edit that alignment, this corridor would update because of that target happening. And you can also see here that my batters are targeting the natural surface. Okay, so as I mentioned, this corridor is built very much exactly how a user would build it. I'd add their baselines, I'd create all the regions, assign all the assemblies, that type of thing. From here, we could create different surfaces. Benefit of the corridor is you can build surfaces from different layers, right? So, if you want layer surfaces that are a sub-base datum or whatever, you can do that. And as I said, we could be working with something from Model Builder. Let's spin this around in 3D. What we should say before going to Object Viewer.
Just before you do spin it around in 3D, well, in fact, no, go for it, because one of the questions that arose about 10 minutes ago was, how can I see this in Model Viewer? And obviously, we're heading straight to Object Viewer. So
I will show that. I will show that. Yeah. Yes, I will get to that one. Okay, so this is Object Viewer. Now, look, the corridor has been known to have performance issues. There are ways around it, but look, once you have the corridor, it's quite an amazing object. You can do a lot with it. So this is the corridor in 3D, and we can see all the different layers here, for the curve, etc. So that's the corridor in Object Viewer. Later on, I'm actually going to output an IFC file. So then we'll see the solids and that type of thing. Okay, there was something I was going to show. No, I'll do that later. Okay, so we've got a corridor, and some people might ask, what happens if I go and add another road, or add some variations, or make some edits to my CSD job? Well, you can just click on Sync Export, and we will update the corridor. We don't actually delete the corridor. We might delete some regions or baselines, but we recreate the corridor, but using the same object, if you like. Okay, so if you've added labeling or created a Civil 3D surface from that corridor, we don't, when you go run sync, that won't be broken. All those references won't be broken. Now, there is a command called manage corridors, and it'll list all the corridors that you've outputted. So I might have other corridors being produced here, there are multiple corridors. When I hit sync, anything that's ticked on here will be updated. So if there's a corridor you've outputted and you don't want it to resync, you just tick sync off. And we can also remove the corridor from the list. In fact, if I click on remove corridor, it will ask me if I also want to delete the corridor from the drawing. Okay. Cool. Okay. So look, as I said, next week I'm going to do a lot more. We're going to cover everything about the corridor. So there's terminology I'm throwing around that sort of going over your head right now. Don't too much. We'll talk about all of that later. The key thing here is we have a corridor which is an exact match to the CSD model that I created, which is really cool.
Andrew, again, another interesting question sort of connected to civil site design. With the sync export, can you include it in the threads so they'll automatically run the process and update the sync?
We are definitely going to be doing that. So in threads, you'll be able to an action will be corridor export and also pipes. So you could build a thread that whenever you ran it, also updated your corridor, also updated your pipes. Although it's not really necessary, the pipes. And I'll get to that a little bit later.
Great. Thanks, Andrew.
So with the corridor, one of the great things about the corridor is the fact that you can extract solids. So once you have the solids, you can then output an IFC file. And as I was sort of saying at the start of the session, the IFC file is your sort of entry to BIM. So if I click on extract solids, I won't do this, I'll just show you the form. But this allows me to output the solids, and we can even add properties to it, property data to those solids being outputted. You can pick what layers they go on, that type of thing. The command Ifc Export will produce the IFC file. So if you are asked to produce an IFC, this is the process to do so. Now I actually have Navisworks, but I'm going to open up this program called BIM Vision. It's just a free IFC viewer. I don't know, I found it years ago and it's pretty nice that it's free and you can just load in IFC files. So I'm just going to import the IFC file that I just created earlier, and this is my civil site design job that was exported to a corridor that was then exported to IFC. And this is the benefit. This is what you get, right? So you get solids for the curb, you get solids for the pavement, and these components can have attributed data on them. By just clicking on here, I can see the volume, I can see that it's asphalt, and that's really what BIM is about. These 3D solids with attributed data. We could take it to Navisworks, do some construction management. We could do some clash detection. We could bring in some buildings. I could bring in a bridge. That's really what it's all about. So so that's the IFC file. Now, as we mentioned earlier, someone had asked about getting the corridor in the model viewer. What we did in the current version 20.3, there's actually a whole bunch of new features we haven't had time to sort of promote yet. But one of those is the ability to now import IFC files. Now, what I've done here is I've created a base surface using the paste surface command, and I just created a hole where my total model is. So you can import an IFC file now. What you do is you go to Objects, Import Object. Let me just make sure I'm in the right spot here. So go to the folder. Now, down the bottom right, you'll see the files we support. So there's OBJ, 3DS, IFC. So I click on IFC, and then I can select that IFC file. Let's give it a name. The next step is to set up the position. Now, my IFC file that I output essentially stores all the coordinates. So all I need to do here is click on Setup Position and click on Apply. But some IFC files, the origin might be 00 or something like that. And in that case, I would need to locate or pick a location for it. So in this case, I just select on Apply and then Import. And then that IFC is being read and will load in any second now. So model viewer in time, we want it to, as people start, embracing BIM and that type of thing, we want to allow you to import IFC, click on components, see the properties, edit the properties, bring in, buildings, bridges, all that type of stuff. And yeah, so there's a lot more we're going to be doing here, but there's that same IFC file from the corridor brought into Model Viewer. Now, what you could do, if I really wanted to, I could also show total model, and you'll see that there's a little bit of Z fighting between the two. But what I could do is just edit that IFC file and just sort of drop it. I'll drop it a fair bit, but I'll just drop it a little bit just so that we don't get that Z fighting between the materials. So I've got the rendered total model and then the IFC file underneath that. Okay. I probably dropped it too much, but you get the idea. Okay. So yeah, that's a new feature, the ability to bring IFC files into Model Viewer. Okay, so look, the corridor is the big ticket item on the Civil 3D Output tab, but there are a few new commands we've added which our users should find very useful. And the first one I want to show is feature lines from model. So I run feature lines from model, this dialog box appears. All you do is you pick the model and the site that the feature lines are going to go into. So once again, we support Model Builder. This is just not a total model only command. And when I go and click on Export, I have a whole bunch of feature lines that have been created. All right, so I can click on the feature line. I can open up the elevation editor. Okay, all right, and we've just populated that with all the elevations. Right, so the beauty of having a feature line, you can start grading using the Civil 3D grading tools. You could build some surfaces by just taking certain feature lines. We will do more on that command later. So this is sort of version 1 of it, but we'll do a lot more on it. The export profiles command has been in the software for a long time, and by running it, it'll produce these profile views. In fact, in your active drawing settings, there's a C3D styles tab, so you can pick what your default style is for profile view output. But this has outputted a whole bunch of profile views for my strings. Now, the thing about these is if I was to go and start playing with the profiles and editing them, that would enforce an update of my corridor. Right? So my corridor is using the same profiles here. Okay. The update strings command, I'm going to show you in a sec. I'm going to come back to that one because the next command I want to show is profiles from codes. This one I think is really, really handy. So the idea behind this one is for any code on my model, I can output alignments for it and a Civil 3D profile. So I'm going to say for road 1, I want to output the inner footpath code, this one here. So for road 1, I want left footpath inner. I'll just go for an offset alignment, and the profile will keep it like that. There are times, and I've had people ask me before, how do I output an alignment quickly for a string or a code on my road? And the answer used to be, well, you have to output a polyline, output polylines first, and then you got to turn those polylines into alignments, and it's a bit of a pain. But this command does all that for you. If I click on export, you can see that I've got an alignment now running along there. That might actually create multiple alignments. If I've deleted part of the footpath and I restarted it, I would actually have more than one alignment. So from my tool space, I've got a new alignment called LFPI. It's given it a unique name there. And there's a profile here on there as well, Design LFP1. So what I'm going to do is I'm going to, this might be an example where I want to independently control the levels on the footpath, right? So at the moment, the footpath levels all stem from the shape of the template, right? But I want to independently control the levels of the footpath. So to do that, as you would know, we would turn it into a string. All right, so I've already got the alignment there, which is cool. So click OK. Now, when we turn it into a string, we create the string, the software puts a design of best fit over the surface. But what I actually want is the current design that's been applied to that footpath. Right? So this is what you do. You just close the VGE and you run this command called update strings. And what it does is any profile that you've been editing in Civil 3D that has the name prefix design dash and then the name of the alignment, which is actually all of these profiles and the one I just outputted, those profiles will then be brought onto the CSD string. Okay, so as I said, if I was to move this profile up, by clicking on this button, it would transfer that Civil 3D profile design onto my CSD design. Okay, so let's run update strings. It'll take a couple of seconds.
We've literally just had this question come in, Andrew. So
It
was editing the profile view from Civil 3D. How does it impact the civil site design, vertical grading design?
Yeah. So this brings it back on. So this is pretty cool, right? So if I go into the VGE now for that string, all right, that profile we're looking at is the current design. All right. So now I can just go and start working with that profile, using the original levels that were signed off the template. So it's pretty cool. That's one of the benefits of this profiles from code. So not only do you get an alignment, but you also get the profile. And then when you create a string, you can put that Civil 3D profile onto your CSD string. So that's what that one does. Okay, so the final thing I wanted to show before we sort of get into some Q&A, I did want to give you a quick example of the Pipe Networks. The Pipe Networks has a similar command to the corridor conversion, sort of like a mapping interface. Let me just go to standard here, whereby you take pipe classes from CSD and you map them to parts and part lists and families and part sizes from Civil 3D. So we've got a really nice interface. In fact, if I go and add a CSD pipe class, it'll try and automatically assign the part size. I actually didn't go in here and pick the part size from Civil 3D. It just looked at the number and tried to work it out. A couple of things you can do when you output the data, you can actually put the hydraulic data from CSD onto the CSD network. So things like the HGL, the flow, junction, pit losses, they all can be put on. If your pipe in CSD is curved, then it'll be curved pipe in Civil 3D. And the other thing, the last thing we're actually working on at the moment, which is pretty cool, is for the branches of your CSD network, we will create alignments out of those, and we will output profile views, and we will automatically add all of the pipes and structures, or pipes and pits, onto that profile view. So that's what we're doing at the moment. So I've already got a CSD network here. I'm just going to drink water. So all I do is click on Export Network, select my CSD Pipe Network, pick the conversion file, so let's go for standard, and the name of the network. So all I do is click on Export Pipe Network, and the first time might just take a couple of seconds. All right, but I actually now have a CSD Pipe Network. So underneath Pipe Networks, there's one here called S-Water. If I go and select that, that's all made up of Civil 3D pipes and pits. In Object Viewer, all right, this is what you get. This is just the very standard, very standard pits and pipes here. The cool thing about this is I've actually set it up to be dynamic, so that if I go and move a pipe in CSD, so I'm just going to move this pipe over there, you'll see the Civil 3D pipe and pit update as well. So while you're working on your CSD network, you can have this Civil 3D network, which is a 3D solid-based network, updating as you do it. So that's pretty cool. So as I'm making those changes, this 3D model is updating. And as I sort of mentioned, I actually didn't put a flow through this system, but just to let you know that if I did, the HGL flow, junction loss, pit loss will be populated in here, and we will add the energy grade lines as well. Okay, so that's all set up. But look, the beauty of having the corridor, having the pipe network, is those 3D solids that can then be exported out as IFC to participate in BIM workflows. But there's actually a lot of other benefits with the pipe network and the corridor as well. For example, there's an add-in program called Trimble Link, which some of you might have, you might use for construction set out. It directly takes a corridor. If you have the corridor, you can use Trimble Link then for set out. So there's a lot of advantages for being able to, produce the corridor. That's the issue in the past with the corridor has often been actually the process of building one with intersections and cul-de-sacs and that. So it can be done. It's just a lot more work involved. So look, there was a lot of content to cover in this session, and I understand if your head hurts after that. However, it is important that you understand that these new tools exist. And as Jonathan mentioned, we have e-learning material that's available so that you can educate yourselves at your own pace watching the videos. So with that, I'm going to hand back to Jonathan. So
no problem, Andrew. We can keep sharing your screen because we've had a couple of questions. One was in relation to whether or not the I'm not too sure which part of the tool they're referring to, but basically the grading strings, how they can be operated.
Okay. So if we thought long and hard about this, if you create a grading string, we don't include it. the thing is, if you're grading something like a basin or something like that, then the corridor is very much a linear design tool, and for things like basins and that, it's very hard to sort of convert to a corridor. I guess the main issue we had is when you have a grading string and you build like a basin or whatever, we do all the corner cleanup, and to do that then on the corridor is hard to do, and so we were just worried we'd just never be able to get a proper match. We could support the grading string, if you used it to do, a basic channel or something, but even then the batters might not turn out exactly how they should. So yeah, we left the grading string because we just couldn't get a good match.
Yep.
So that's yeah.
Okay.
And if you're doing that type of thing, then you're probably best leaving it at that, because the corridor's not really meant to hold those types of objects. I guess it's mainly for these linear roads and whatnot.
Another question. Someone's got historical or old pipe designs in Civil 3D that they've wanted to convert and bring into Civil site design, which I think we're basically saying, look, can we bring it the other way? So instead of going out to Civil 3D, can we go back?
Yeah, there's actually no reason why we couldn't do that. Because of the nature of pipe networks, they're just nodes and whatnot. Yeah, we could certainly do that. The reason why we haven't is what drives our development is user feedback. So we haven't had many people ask us that one, because we don't have many users that are using the Civil 3D pipe network. They'll use our software to do it and do the analysis and whatnot. But yeah, if we had a lot of people wanting it, we could do it. If the question was, I have a corridor, can I convert that to a CSD road network? Yeah, that's pretty much almost impossible for us. But yeah, the pipe network we could do if it, if we had a number of users come to us and say yes, that would be great. Yeah, we could do it.
I think certainly, if you have a lot of people haven't ventured into Civil 3D, a lot of people have sort of started with civil site design and gone across to Civil 3D rather than necessarily going the other way. It's interesting that this particular person has actually got old designs. In fact, they're asking about just adding the pipes as an XML import.
Actually, that would be a good way to do it.
Yeah,
because then you can support networks that might come from other programs. So yeah, an XML import would be the way to go.
Yeah. We have got another question, but not entirely sure of the. It's outputting the civil site design template to Civil 3D as an assembly in the sublay. Will it change the civil site design template? That will not work if the template was set up with variations as it's hard coded. Not quite sure of the question there. I'm
not sure either, but let me just recap something. So what we do is we cut sections off your road, and from those we build assemblies. So if it's the same assembly as the last section, then we're not going to just create a new assembly, right? So we have an assembly, and the assembly is very generic. It's just sort of standard nominal widths and whatever. Okay, so in order to set the levels, the correct width and slope or whatever, either we use targeting. Actually, there's a setting I should show you in a sec, or we apply the right slope by using parameter edit the parameter override. So on a particular section, we might go in and force a parameter override, which doesn't look like there's any on that section, but you'll see that when you output your corridor, you might see that, for whatever reason, in order to get the slope, because maybe you added variations, change the width, we might do that by adding a parameter override. Parameter override's a little bit messy, so we like to use targeting as much as possible. And I didn't mention this, but in the corridor settings, so if we expand out corridor settings here, there are actually some settings related to the corridor export. So, you know, my cul-de-sac and my intersection here is all made up of targets, right? So I can actually, you know, move this alignment, and the corridor or the intersection will all hang together because it's all done using targets, right? The same way that a user would do this manually. However, if you didn't want to use targeting on the corridor, you can tick those off, and every edit to the section becomes a parameter override. So, you know, on this baseline here, in order to achieve this at the intersection, at each section, that R-dum width and slope would have a parameter override. So I don't know whether I answered the question, but you know, it did prompt me to remember to mention this settings and talk about, you know, sometimes we use targets, sometimes we use parameter overrides, but yeah, these assemblies we try and keep them standard, so you don't have 50,000 of them.
So, yeah, look, at the moment we have no other questions. So, guys, this is probably the best opportunity you'll get to ask further questions in this particular webcast, just before we give you a quick overview of the e-learning portal that we have available for all civil site design users, not just specifically related to this particular tool. But what I might do is just leave the Q&A panel open, just in case anybody gets anything particular they want to ask. And what I'll do is I'll share my screen, if that's all right, Andrew. So hopefully you can see my browser. For those of you that aren't aware, in February we released basically an online learning platform, and you can see the link for this in my web browser. You can actually find it directly from our Civil Site Design or Civil Survey Solutions websites on one of the menu pull downs at the top under Training. And we decided to create the Civil Site Design Fundamentals course entirely online. If you do find yourself in a position where you've started using the software for the first time and you'd like to learn, or you're an existing user, because certainly there's a lot of features in the software that have gone in over the years that existing users may not necessarily be aware of, or even the way in which the software can now sort of be trained. Let me just quickly give you an overview of this, just to show you what it can do. I will mention the e-learning course, what you've just been seeing, just very shortly. It's entirely free. If you want to log in, you can register for the school. So any courses that we create, you'll be able to see, and then you can enroll on a particular course. So this is one here is Civil Site Design Fundamentals. Now, all being well, we can load this up. You can see here we've got the course, and within that we've got a vast number. We've actually got nearly 100 videos, and the idea is that you can learn civil site design from scratch all the way to the end. So we've got labels, grading, strings, models. This is a workflow, so you can jump in at any point and then continue that workflow. These are not just separate lessons, all completely individual, but they're videos with data sets. So if you want to know more about, let's say, what Andrew did earlier, which was profile strings, you can click on profile strings and open up a data set associated with it, which is basically a follow-on from the one behind. And you can basically start the videos and follow them along. And then something we mentioned earlier, which was threads. There's a little bit on threads at the end. So this is nearly 8 to 10 hours of video material, really extensive learning material that you can get your hands on. The course, for what you've been watching today, is available here. So we launched this morning, and we can, as you can see here, we click on this, you can enroll. Again, it's absolutely free. And then it's video-based learning. There's Terry, who's put the course together. And again, we've got things like data sets, and then videos, which you can follow all the way through. So really, really good learning resources. You don't have to learn it and do the whole course. If you want to jump in and learn something about, for example, exporting profiles, then you can do that in there. So really, hopefully, really good resource for many of you to get your hands on. Now, what I'm going to do is just quickly fire up the last slide. Thank you very much for attending. Andrew, I don't know if you've got any sort of final comments. We don't seem to have had any more questions come in on the Q&A panel, but is there anything you sort of wanted to finish off with?
Yeah, look, firstly, thank you for attending. If you do have any other ideas on how we can better connect with Civil 3D, certainly at the moment we're working on the pipe stuff. Don't be shy. Feel free to email us and get in contact. I like to think that the great thing about you guys being able to work with a company like us is that you can, sort of be involved in the development. So, don't be shy and get in contact with us if you have ideas.
Yeah. So yeah, no, thank you very much, Andrew. That was absolutely fantastic. Really great overview. Thank you very much for attending, folks. And we look forward to catching up with you soon. Keep your eyes peeled on the YouTube channel as well for the recording of this particular webcast. But thanks very much. Have a good day.